Today, let us start with lesson alcohols, phenols, and ethers. First, alcohols. Phenols have functional group Al as minus OH, and ethers have functional group as O. Here, alcohols, the functional group OH is directly attached to the carbon atom. Then they are called as alcohols. Now, types of alcohols. First is monohydrate alcohols. For example, here you can see CH3OH or CH3H3, C2H3OH. One OH group is present. Then dihydrate alcohols, example CH2OH, CH2OH, known as glycerol, where two OH groups are present. Then trihydrate alcohols like OH, HO, CH2, CHOH, CH2OH. Here it is known as glycerol, which has three OH groups. So it is known as trihydral alcohols. Now alcohols are of three types: primary, secondary, and tertiary. Primary alcohol, example, here you can see C is attached to CH3, 2H and OH. Then secondary alcohol, that is CH attached to OH, then CH3. Then tertiary alcohol attached to three groups of methane, that is CH3 and OH. Now let us move on to the nomenclature of alcohols. First is the common system of nomenclature. Now here we can see, first find the alkyl group and add alcohols and as suffix. For example, alkyl plus alcohol. Then CH3, example CH3OH. Here the name is given as methyl plus alcohol, so methyl alcohol. Then here another example, CH3OH. Here isopropyl alcohol. Then another structure, three sides CH3, that is CH3, then CH2 attached to OH. Now here we can see neo is added first, then pentyl, then alcohol. Now second type of nomenclature is carbinol system of nomenclature. Here CH3OH is called as carbinol. Wherever CH3OH is present, it is named as carbinol. Here you can see CH2OH, so we will call it as methyl carbinol. Then CH3CHOH we will call as dimethyl carbinol. Now IUPAC system. Here first word root is given, then suffix, then we'll add OL at the end. For example, here you can see CH3, CH2, CH attached to CH3, then CH2OH. Now we'll give this name. Now first we have to count the number of carbons. Here you can see 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. There are 5 carbons in this structure, so we will name it as pent. It is methane, so we will write N plus OL. We should not include this E, so we have to cut it. So we will get the final answer as pentanol. We have methyl here at the second carbon atom, so we will mention it. 2-methyl pentane 1-ol. Now another structure. Here the structure of ethene, you can see the functional group of ether is here. It is attached with carbon and hydrogen, which is sp3 hybridization and bentene structure. Now here you can see, let us discuss about isomers in alcohol. First is here the first isomer in alcohol is chain isomers. For example, here you can see C4H10O. is present as a structure. If we draw it like this, 1 2 3 4 4 C OH 1 OH, then 10 hydrogen, 1 hydrogen, 2 3 4 5 6 7 8 9 10. Okay. Or we can draw this, we can build a structure like this, like 1 2 3 4 5 6 7 8 9 10 hydrogens are present, then 3 4 carbons and OH. Both are same, but the length of chain is different, so they are called as chain isomers. Now here you can see another second type of isomer in alcohol, which is positional isomers. For example, here you can see the number of carbon atoms, 1 2 3 4 carbon atoms with 1 2 3 4 5 6 7 8 9 10. The same structure as C4H10O here, which can also be written as the position of OH may be given here. So the structure and component formula is same, but the position of the functional group is different. So it is known as positional isomer. Here you can see only the position of functional group is different, so it is known as positional isomer. Now functional isomerism. Here same molecular formula is present, but different functional groups are called present, so they are called as functional isomers. For example, here you can see CH3 CH2 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 OH is present, then CH3 CH2O CH2 CH3. Here the alcohol functional group is present, here ether functional group is present. So the molecular formula is same in both of these, but the structural functional formula of this is alcohol and it is ether. So by this we can say they are two functional isomers. Now here optical isomers. Here you can see the structure of this compound, CH3 CH2 CH3 HOH. Here it is a cylindrical carbon and optically active alcohol. Now preparation of alcohols. The first method of preparing alcohol is from hydrolysis of alkyl halide. Here you can see alkyl halide. When it's mixed with aqueous KOH or H2O or AgOH, it gives ROH, that is alcohol. Primary alkyl halide gives alcohol, then secondary alkyl halide will give alcohol plus alkene, then tertiary alkyl halide will give alkene, which is major product, and small amount of alcohol. So first primary and secondary are used, halides are used for production of alcohol mainly, then the tertiary alkyl halide. If hydrolysis proceed via SN1 mechanism, then the rearranged products may be obtained. Here the second method of alcohol formation is hydration of alkenes. First is direct hydration, that is addition of H2SO4. Here first you can see CH2 added with concentration H2SO4 to give rise to CH3CH2SO4H, and now it is boiled with hot water, then we'll get CH3CH2OH, which is alcohol. Then second type example is CH3CCH3 double bond CH3 plus H2O, now added with concentric H2SO4, then we'll get this CH3COH CH3 CH2 CH3, which is alcohol. Now it is electrophilic addition reaction which proceeds via formation of carbocation, so the reagent products may be obtained. For example, here CH3CH, CH3CH, double bond CH3 CH2 plus H2O added with H plus ions, then we'll get CH3C, CH3H, CH, then CH2H. Here you can see. Here this hydrogen will go here and gives plus symbol. Here secondary carbon, here you can see. Then hydrogen shifting will occur and it forms this type of structure. Then OH minus is added. Finally we'll get the tertiary alcohol. Now second example, here you can see the ring is given which CH attached, then CH2 plus H2O. Here H plus ions are added to give rise to here plus. Here ring expansion will take place like this. Then ring will expand to form 6 numbered ring, which is more stable. Then it may undergo two types. First, it may take OH minus ions and form like this, OHCH3, or hydrogen shifting may occur like this, and again OH minus are taken, and it may finally end like this. Both are equal, both are same, but this is easy method, and the ring structure is more stable than normal structure. Now third is indirect hydration. First is hydrocarbonation or oxidation reaction. Here CH3, CH, CH2, then B2H6 or THF. Then secondly, it is added with H2O2 or OH minus to give rise to CH3, CH2, CH2OH. It is anti-Markov addition product. Now mechanism, here you can see CH3CH double bond CH2 added with BH3 to form CH3CH CH2, which forms hydrogen bonding with boron hydrogen. Then transition state, H is added, CH3CH2 CH2 BH2, then 2CH3 minus CH double bond CH2 is added, then we'll get CH3 CH2 CH2 and B, which is trialkane borane. Now it is added with H2O2 or OH minus ion, which is second step, to form 3CH3 CH2 CH2OH, which is alcohol finally. No possibility of rearrangement is seen in these structures. Here you can see once again mechanism. Now the second method is oxymercuration or demercuration. Here CH3CH2 is added with CH3CO6 2H6, and secondly with LiAlH4 to give rise to CH3CH3OH. Now here we can see the mechanism of this structure. Here CH2 plus Hg is added, where Hg forms like this structure, OOCH2 CH3. Then hydrogen bonding occurs here like this. Then this structure will arise, as you can see here, the mechanism. The next structure is here, as you can see. Then finally we'll get CH3OH CH2H, which is alcohol again. Now fourth, from Grignard reagent we can obtain the alcohol. Reaction with carbonyl compounds, like this, carbonyl compounds. Here added with RMgX to form C minus, then MgS are intermediate mediate here like this. For example, first example, HHCO R max and H3O is added, then we will get CHHOHR, which is primary alcohol. Here you can see secondary, then tertiary alcohol also can be obtained. So from this carbonyl compounds, reaction with carbonyl, we can obtain primary, secondary and tertiary alcohols, as you can see. Here reaction with esters. Example, here you can see HCO CH3 double bond O, which gives rise to secondary alcohol. Then second example, which gives rise to tertiary alcohol. Here primary alcohol cannot be obtained by this method. With reaction with esters, we will not get primary alcohol. Now here you can see reactions with epoxides. Here with reaction with epoxide, will get the alcohol as result in both cases. Here you can see the reactions as given below. Then now let us move to the next page. Alcohols formed from the reaction of carbonyl compounds, acids and esters. Here you can see carbonyl compound first, which forms primary, secondary and tertiary alcohols, where reduction of carbonyls can be done by LiAlH4, NaBH4, sodium or alcohol, aluminium propoxide. Here NaBH4 can reduce by C double bond O and C double bond O Cl, but cannot reduce other functional groups as C triple bond C, C double bond C. For example, here you can see. Then LiH4 can reduce carbonyl groups CCl, then COH, ester, NO, CN, but cannot reduce C double bond C. For example, here you can see. Now in the example here you can see there are two examples. First is this, both LiH is used to form the alcohol as final product. Now let us move on to the next page, which is reduction of ester. Here in reduction of esters, here you can see the examples. Then the reduction of RCOH, which is common reducing agent like LiAlN4, Na plus alcohol. Here you can see reaction. Then from primary amines, RNH2 plus H2O will form ROH plus N2. From saponification of esters, here you can see CH3CO C2H5 plus H2O under presence of NaOH gives rise to CH3COO Na plus C2H5OH. Now industrial preparation of alcohols. First is hydration of alkane, second is fermentation of carbohydrates, for example C12H22O11 under presence of water, invertase, which forms into glucose, which is CH3C2OH plus CO2, then fructose. Now properties of alcohol. First is physical properties of alcohol. First is physical state. Lower alcohols are liquid and higher alcohols are solid in state. Boiling point. They have high boiling point than haloalkanes or alkanes of same molecular formula. For example, alcohols are greater than haloalkanes, greater than alkane due to hydrogen bond. Then haloalkanes have dipole, whereas alkane have van der Waals forces, which is boiling point order of this. Alcohol greater than haloalkanes greater than alkane, which is boiling point order of these three when compared to each other. Now let us move to the next page. Here you can see, as the boiling point increases, the molecular masses increases. For example, CH3OH less than CH3CH2OH less than CH3CH2CH2OH. The isomeric alcohols boiling point increases with branching. Here you can see there are three examples like N-butyl alcohol, isobutyl alcohol, tetrabutyl alcohol. Here one is greater than, two greater than, three has. The first one has more number of branching. So first, then second, then third. Now solubility. Alcohols are soluble in water due to hydrogen bonding. They have both hydrophilic and hydrophobic head. As size of alkane group increases, its stability in water increases. In water decreases. So CH3OH greater than CH2OH greater than CH2OH. Now isomeric alcohol. Here solubility increases as size of alkyl group decreases. CH3 CH2 CH2 CH2OH, then CH3 CH CH3 CH2 COOH2, then CH3 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 COH3. Here you can see the order. 1 is less than, 2 less than 3. Formation of alcoholics. Alcohol cannot be buried using aldehyde CaCl3. Now, chemical properties of alcohol. Let us discuss about some chemical properties of alcohol in the next page. But first, let us see the examples of formation of alcoholics. Here 4OH3OH plus CaCl2 gives rise to CaCl2, 4CH3OH. Then 2C2H5OH plus CaCl2 gives rise to CaCl2, 3CH3 CH2OH. Now let us see about chemical properties of alcohols. Here are the chemical properties. Alcohol behaves as acid and base, so it is known as amphoteric substance. First, acidic nature, neutrophilic substitution reaction, then alcohol as well. First is acidic nature. Here you can see ROH plus Na gives rise to RONA plus half H2. Here the comparison of acidic strength. H2 is stronger than alcohol. Then acidic strength in primary, secondary and tertiary alcohol. Here you can see if the plus I effect decreases, the acidity of alcohol increases. As you can see, CH3OH greater than primary, then greater than secondary, greater than tertiary. Acidic nature of alcohol. Acidic nature of alcohol is directly proportional to stability of anion. If minus I effect increases, the acidity of alcohol increases. CH3 CH2OH is minus plus I, which is less than CH3 CHOH, which is minus I. Now CH3OH is stronger acid than H2O. Now here you can see when ROH is added with NaKCl, what is metal, then it gives rise to RONA plus half H2O. Then NaOH, no reaction. Na, it gives ether, which is known as Williamson's synthesis. Then which is added with CH3COH, then it gives ester. CH3COCl and CH3 CO2O are also added with ROH to give ester, which is known as esterification reaction. Then RMGX is added to form alkane. Now let us discuss about esterification reaction. Here you can see the formation. The rate of esterification reaction decreases as the size of alkyl group in alcohol or carboxyl acid increases. Average given alcohol increases in order of their reactivity towards esterification. For example, the order is CH3OH, CH3 CH2OH, CH3 CH2 CH2OH. Here 1 greater than, 2 greater than 3. As size increases, the rate will be decreasing. Then in the second question, as you can see, which of the following alcohol react fastest with the aluminium metal? The given compounds are CH3OH, CH3 CH2OH, CH3 CH2 CH2OH. The acidic strength and stability of metal reaction are same. So the following comparison is 1 greater than, 2 greater than 3. Though CH3OH plus aluminium gives rise to CH3O3Al plus half plus 3 by 2 H2. CH3 CH2OH plus Al gives rise to CH3 CH2O Al. Now nucleophilic substitution reaction. Here ROH is added with HX to HX, that may be HCl, to form RCl. It may be HBr to form RBr. It may be HI to form RI. Or ROH is added with PCl3 to form RCl. It is added with SOCl2 to form RCl plus HCl plus SO2. Then it may be added with NH3 to form RNH2. Now reaction in which the whole molecule participate. First is oxidation of KMNO4, CrO3, K2, Cr2O7, etc. Here you can see the example. Some more examples are seen here. Secondary alcohol is used and here tertiary alcohol is used. Then no reaction is formed. Now reaction with concentric H2SO4. CH3 CH2OH in different temperature it is added with H2SO4 to form different ions, as you can see here. In room temperature CH3 CH2OH H2SO4 is formed, that is oxidinium salt, and in 110 degrees Celsius the molecule formed is this CH2 CH3 H2O plus H2O and CH3 CH2OH CH3 CH2SO4. And in 140 degrees Celsius it forms CH3 CH2O CH2 CH3 plus H2O, and in 180 degrees it forms CH2 CH2 plus H2O. Now dehydration of alcohol. Here you can see beta elimination reaction. The reagent is concentrate H2SO4, temperature KHSO4 or Al2A3, catalyst is used. Mechanism. Here step 1 H2SO4 gives rise to H plus plus SO4 minus. Here you can see. Then step 2 is the rate, but here after 2 steps you can say that the rate is directly proportional to the stability of carbocation.